Alright, we're solving some trig equations now. We're going to be using the arc sign, but we're going to be using a lot of some old algebra techniques as well. So in this original problem here, we have 2 sine of theta minus 1 equals 0. Really, I want to think of this sine of theta as just one big x, and I want to solve for x. How do I do that? Well, I'm going to start by adding 1 to both sides to give me 2x, or 2 sine of theta, is equal to 1. Now how would I get that x by itself? Well, I divide by 2. So sine of theta will equal a positive 1/2. So now, what I would be doing technically here is to take the arc sine, or the inverse sine, of both sides. The way that we're going to think about this is what values of theta would give me 1/2 for a sine value. So if I'm looking at my chart, if I'm looking at my unit circle, or even if I plug into a calculator, when is sine equal to 1/2? Well, sine is equal to 1/2 at 30 degrees. The next question is, well, we're looking at a positive number. What quadrant should we be looking for? Sine is positive in quadrants 1 and 2. So 30 degrees in quadrant 1 is 30 degrees. So theta is 30 degrees. What else is it? In quadrant 2, it's 150 degrees. If I was using in radian mode, this would be pi over 6, and this would be 5 pi over 6 for my values there. So look at another example, see what we can do here. 2 cosine theta minus the square root of 2. Again, think cosine theta as a big X. How do I get it by itself? 2 cosine of theta will equal the square root of 2. To get it by itself, I'll say that cosine of theta will equal square root of 2 over 2. When is cosine equal to square root of 2 over 2? Well, first, cosine is positive in quadrants 1 and 4. The angle that I'm going to have here is 45 degrees, so that means in quadrant 1 it is 45 degrees for theta. And in quadrant 4, I would do 360 minus 45, which means 315 degrees here. So I want to do my radian mode, pi over 4, and 7 pi over 4 for these. One more example here. This one, now we have some cosine squares. However, again, just think of this as an equation like this. 4x squared minus 2 equals 2x squared. Look at it something like that. What would I do? I would combine my like terms. So I'm going to bring this 2x squared over by subtracting 2x squared on both sides. I'll have 2x squared minus 2 is equal to 0. I can now say, well, that means 2x squared would equal 2. If I divide both sides by 2, it means x squared will equal 1. From here, well, x squared is, this we're saying is cosine squared theta equals 1. So I want to look at it that way, which is the way I need to. So, cosine squared theta. That is the same thing as saying cosine of theta, the entire thing, squared. So, to get that cosine theta by itself, I need to take the square root of both sides. Well, the square root of 1 is 1. However, I need to say plus or minus because I introduced a square root here by taking the square root of both sides. So, cosine of theta equals plus or minus 1. What does that mean theta equals? Well, when we look at our chart, we might be a little deceived or we might predict something. So the best way to look for the 1s and 0 answers here, when this is 1 or 0, is to look at our unit circle. When on our unit circle is my cosine, my x value, equal to 1 or negative 1? Well, right here, at the beginning, we're going to have an x value of 1. And when we get around to here, we have an x value of negative 1. And 1 over there. So that means theta right here at the beginning was 0 degrees. And over here was at 180 degrees. Or if I do radians, that would be 0 and pi radians. And that's the beginning. We're going to get a little bit more in depth with this, but for now, this is a good start for